Hi everyone. Today I will explain my project on research via LinkedIn on the automobile technology trends. So first, we can see that the China market has emerged as the leader in sales volume and has a significantly high number of OEMs. So BYD, Geely, Leap, XPeng, and yeah. And we can see that legacy brands are on the top of the leaderboard for satisfaction and reliability in the global OEMs. And now let's look at the future of mobility. So the automobile world is seeing the convergence of EV, autonomous, shared, and connected technologies. These technological advancements are enabled by software-defined vehicles. So first, electric. Electric basically refers to the increasing adoption of electric vehicles, which we are already seeing. Next, autonomous. Autonomous basically encompasses self-driving vehicles that can operate with minimal or no human intervention, using technologies like sensors, cameras, and AI to navigate and make driving decisions for us. Next, shared. Shared focuses on the concept of vehicle sharing, where multiple users utilize the same vehicle, often through ride sharing or car sharing services. Next, connected. Connected describes vehicles equipped with technologies that allow them to connect to the internet of their vehicles and infrastructure. And this is basically technologies like V2V, V2X, and V2I. And then we have our software-defined vehicles. Software-defined vehicles are characterized by a high degree of software control over various vehicle functions, from powertrain and chassis to advanced driver assistance systems and infotainment. So in other words, we could basically say that the electric, autonomous, shared, and connected is what the future entails, but the software-defined vehicles is how this future will unfold. Okay, now we have the electric vehicles. So EVs, as we all know, EVs have become increasingly popular because of their low running costs and for simplified manufacturing. And we know BEVs have been proven to be effective for distance travel. PHEVs and REEVs are preferred for longer distances. Autonomous vehicles. Most vehicles are in the level 2. Partial automation functions for steering, braking, accelerate, lane, and parking assist. Automotive electronics cover a wide range. So let's say power electronics, control electronics, sensor electronics, communication, infotainment, and navigation. Furthermore, next-gen vehicles. So as mentioned before, the next gen basically includes autonomous and software-driven vehicles. And this will be done, autonomous vehicles will be achieved by using a multitude of sensors within the vehicle, which are processed in ECUs for different functionalities by programs. Software programs can be updated to enhance vehicle functionalities by over-the-air updates. So we could kind of say a car is like a phone on wheels. And let's look into the how. Here you can see a mix match of several sensors have been used for different vehicle functionalities. Since every sensor type has their own unique capabilities. And sensors and their respective ECUs have been arranged in different configuration. And this is also known as the electrical architecture of a vehicle. Traditional architecture has 70 to 100 ECUs, each for their own unique function. While zonal architecture has 7 high-performance ECUs, which enables modular, harness, and simplified builds. Traditional architecture have ECUs and MCUs dedicated to perform unique functions. Advanced architecture has system on chip, which can perform multiple functions in the vehicle zone. SoCs are connected via SIM to receive the over-the-air updates, which we previously mentioned. We can see here that OEMs are partnering with suppliers for MCUs and SoCs. As you see, NVIDIA is collaborating with every single OEM here. Furthermore, sensors and SoCs are arranged in vehicle zones to address the different functionalities in the zone. These zones are connected by vehicle Ethernet, which we can see clearly here, the green lines. Oh. OEMs like Rivian are making significant technology advancements in zonal architecture. This resulted in the savings of 20 kg body harness and 60% less line connectors. Zonal architecture has clearly defined zones of system on chips and connected sensors. And Ethernet ensures information highway within the vehicle, thereby ensuring super fast computations required for ADAS and other functionalities. Moreover, autonomous and software-driven autonomous vehicles are software-driven vehicles, right? So different layers of software and hardware architecture are being developed by various OEMs, which ultimately will result in the standardization and adopted in various platforms. And as mentioned before, NVIDIA has partnered with various OEMs like Mercedes, Toyota, NIO for their AI system on chips, such as Orin and Thor. This is because they lead technology advancements through semiconductor chips for AI SoCs. And you guys may have heard of the Tesla and Waymo buzz. So Tesla and Waymo are approaching autonomous drive in two distinctly separate approaches. So as we all know, Tesla is banking on an AI software stack with cameras only as sensors, while Waymo is ensuring reliability via a suite of sensors coupled with a software stack. Next, OEMs are hugely invested in technology innovations led by VW, BYD, SAIC, Li Auto, Geely, and Mercedes. Major SoC players. So we can see here that Samsung, NVIDIA, TSMC, and Qualcomm are the big players in semiconductors for automotive applications. Tier one suppliers and few OEMs are focused on grabbing market in different domains such as ADAS, sensors, SoCs, and navigation. So technology leaders such as Amazon, Apple, Google, and so on, are focused on capturing market for software services and solutions such as in-vehicle, cloud, and others. And that's the end of my research via LinkedIn on the auto technology trends.